Unit number 4, curve tracing. So here we want to study curves in the polar form. So before we start with the curves in polar form, we'll understand what the polar coordinate system is. So the polar coordinate system consists of a straight line. This is the straight line OX, known as initial line, and a fixed point known as pole. Coordinates of a point in the polar coordinate system are r and theta, where r is the distance of point P from the pole. This is the distance r, and theta is angle made by OP with the initial line. So this is the angle theta. Angle is measured anti-clockwise. Whenever it is measured clockwise, it is negative. So to understand the polar coordinate system, we'll go through few examples. So question is like this: show following points on the polar plane. First point P 330 degree. So r equal to 3 and theta equal to 30 degree. So draw initial line, then draw a line theta equal to 30 degree, the line which makes angle 30 degree with the initial line, and on this line take distance r equal to 3. So start measuring distance from the origin, pole. So 1 unit, 2 unit and 3 unit. So this is the point P 330 degree. Next, B point Q 5 minus 45 degree. Note that here theta is negative. So r equal to 5 and theta equal to minus 45 degree. So draw the initial line OX, then draw a line theta equal to minus 45 degree. Here we have to measure angle clockwise. Therefore start from initial line and clockwise. So this is the angle minus 45 degree. This is the line theta equal to minus 45 degree. On this line we want to take distance r equal to 5 unit. So 1 unit, 2 unit, 3, 4, 5, and thus we get the point Q 5 minus 45 degree. Next, C r minus 460 degree. Note that here r is negative. So r equal to minus 4, whereas theta equal to 60 degree. So again draw the initial line OX, then draw a line theta equal to 60 degree. But since r is negative, we don't have to show the r on theta equal to 60 degree, but we have to show that on its extended part. So extend the line by 180 degree. So this is 180 degree, and this is the extended part. So on extended part, take distance r equal to 4 units. So 1, 2, 3, 4 units. So this is the point r minus 460 degree. To trace a curve given in polar form as r equal to f of theta. So first point is symmetry. Inside that, 1, if equation of the curve, that is r equal to f of theta, remains unchanged when theta is replaced by minus theta, then the curve is symmetric about the initial line, that is x-axis. Second, if the equation of curve remains unchanged when r is replaced by minus r, then the curve is symmetric about pole, that is origin. For example, r square equal to a square cos 2 theta. If we replace r by minus r square is again r square, that is the equation will remains unchanged, and therefore this curve is symmetric about the pole. Third, if equation of curve remains unchanged when both r and theta are replaced by minus r and minus theta respectively, then the curve will be symmetric about y-axis. Fourth point, if the equation of curve remains unchanged when theta is replaced by pi minus theta, then curve is symmetric about the y-axis. So the point C and D, they corresponds to symmetry about the y-axis. So what we'll do now, we'll summarize whatever we studied in above 4 points. So if equation of curve remains unchanged, first point is what we have to replace, and second, symmetry about a particular line or about the pole that we are writing here. So theta replaced by minus theta, if equation of curve remains unchanged, curve is symmetric about initial line. R replaced by minus r, symmetry about pole. Theta replaced by pi minus theta, symmetry about y-axis. R replaced by minus r and theta by minus theta, symmetry about y-axis. Second is pole. So curve passes through pole if r equal to 0 for any value of theta. And whenever curve passes through the pole, we have to find tangent to the curve at pole. So to find tangent to the curve at pole, we have to substitute r equal to 0 in the equation of curve. That will give different values of theta. Those values of theta will be the straight lines, and those straight lines will be the tangent to the curve at pole. Third, angle between tangent vector and radius vector. So the angle phi between tangent vector and radius vector is given by tan phi equal to r d theta by dr. Fourth point is existence of the curve. Two different parts are there. A is to find maximum and minimum value of the r. So take different values of theta and find minimum and maximum value of r. Suppose r maximum equal to b and r minimum equal to a, where both a and b are positive, and no doubt a will be smaller since a is the minimum value and b is the maximum value. Therefore, so the conclusion is the curve will lies between the circle r equal to a and r equal to b. So r equal to a is the smaller circle, so minimum value of r is a, so curve cannot lies inside the circle r equal to a. Maximum value of r is b, so curve cannot lie outside the circle r equal to b. So thus the curve will lie between the circles r equal to a to r equal to b, between these two circles. Next, we want to check the existence between the different tangents. So whenever r square is negative for a particular value of theta, say for theta equal to theta 1 and theta equal to theta 2, then the curve will not exist between these two values. Next is table of values. Considering existence and symmetry of the curve, take different values of theta and from there find the values of r. Last point is tracing of the curve. Considering all above points, that is symmetry, whether curve is passing through pole or not, then angle between tangent and radius vector, existence of the curve, and values in the table, trace the curve.